Hi, I'm Dr. Raj Shah of Math Plus Academy, and this math treat is about balance weights. Here you see a traditional old school balance where you can put weights on both sides and try to balance things out. And in order to measure things that have different weights that you don't know, you have to have a set of calibrated weights that you can put on one side that you know the values of, and then measure them against your mystery object that you want to measure until it balances out, and then you can figure out what the weight of the thing is. For example, if I had something that happened to weigh 12 grams and I put it on one side of the balance, of course, and I leave this side empty, of course it'll go out of balance, this side will go down. And so I might start taking weights from over here and placing them in. Maybe first I put in a 10 and the thing comes close to balancing. And then if I put in a 1, I'll get really, really close. But if I want to actually put 12 on this side, I got to take the 1 out and put a 2 in, and a 10 and a 2 would of course balance with my mystery object that weighs 12. And so you can measure the weight of objects this way if you have a calibrated set. Now I did some research on the internet and I found that you can get these calibrated sets, and they come in sets like this where you get a 1, 2 2s, a 5, 2 10s, 2 20s, a 50, 2 100s, and so on. And you could certainly, with this set, probably measure up to at least 250 or more grams. Let's say that these are all in grams with this set. So a question you might have is this the optimal choice of weights? Who decided we should have 2 2s and 2 20s and 2 10s? I can tell right off the bat that if I want to measure something that's 50 grams, there's multiple ways to do it. I could put just a straight up 50 on there and balance it with something that weighs 50. Or I could take 2 20s and a 10 to make 50. Or, geez, I think these all add up to 10. So I could take all of these and a 20, that's 30, and 2 of those. And there's so many different ways to make 50. So is that really the most efficient set of weights that I should want to have? Or is there mathematically a more efficient set? And also with this set, I presume somebody's done the work, but can you even measure all values, all whole numbers of grams from, let's say, 0 to 250 or 1 to 250? I suspect you can, because if you can't, then you probably shouldn't buy this. But I haven't actually double checked. So that's one thing you might want to check first off. Then think about, can we find a more efficient set? Like, are there weights where there's only one way to get every number that you want? There's only one way to measure 1 and 2 and 3 and 4 and 5. Not like this where there's at least 3 or 4 ways you could measure something that's 50 grams. So look for the most efficient set of weights that you could use all on this side to balance something on this side, where you could produce all the values from 1 to 250. What does that set look like, and how many weights do you actually need? Can you do it in fewer than what's up here? 4, 6, 8. There's 11 up here. Could you do it in less than 11 calibrated weights? If you could sell those and maybe save people some money and make some money for yourself. Now, that's just one way to sort of have an optimal set, where you put your mystery object on one side and you put all your calibrated weights on the other. But think about this. What if I'm allowed to put calibrated weights on both sides? So suppose I had something that weighed 4 grams that I wanted to measure. I put that on one side. I could actually measure that by putting a 1 gram weight over here with it to make it into a 5, and balancing that with a 5 over here. So with these 2 weights alone, I could actually measure something that weighs 4 grams by taking the difference between them. So that's different than the original question. The original question was if you put them all on the same side, so you're always adding these values up. Now let's actually look at the differences. That opens up a whole nother set of possibilities. Will you be able to measure all the weights from 1 to 250 with even fewer weights? Don't know. Those are your mystery challenges for this math treat. Can you find an optimal set of weights where you're only putting them on one side and you can make every number from 1 to 250? And can you find an optimal set of weights where you're allowed to put them on both sides so you can leverage the differences to get all the numbers from 1 to 250? what did those sets look like? Will you need repeated numbers, or will they all be unique? I don't know. So as always, start playing around with this and just have fun playing with the math.